Hey there, Nick Jatakis here. In this video, we're going to go over backing up and restoring your self-hosted database in Docker. So we're going to focus on using Postgres here, but if you're using MySQL or a different database, no problem, you can just swap out some of the commands. Likewise, if you're not using Docker, you can just remove out those commands as well. So in this video, I'm not going to be narrating this blog post to you here, but it really is going to be like 7 tutorials in one, because we're going to go over how to perform daily backups with just Postgres and a cron job, how to back up your database to a file system, what could be a local file system, a network mount, a block storage device that you mounted in, or an S3 bucket. Then we're going to do the opposite of backing up, right? Super important. We're going to go over how to restore your database from that backup. Then we're going to go over how to use the free and open source version of Plakar, which can save you quite a bit of money when it comes to your database backups and restoring. You know, it's a really great project here. I've been using it for a bit, so we're going to focus on that in the second half here. And along the way, it's really going to be a crash course on how to use Plakar for both local and S3 storage here. And if you want to use a different storage engine besides S3 to save your backups to and be able to restore from, it supports more, but more on that later. Then yeah, we're going to go over how to perform daily backups using Plakar, as well as being able to restore your database as well. Now, I am super skeptical on using third-party tools here, especially for something as important as backups, but Plakar has a lot of really interesting features that can help reduce complexity when it comes to setting all this stuff up, as well as saving you time and money. Now, you know, I'm not going to read everything here, but needless to say, right, your data is really important, right, for companies here. If you were to lose your database, that could be a company-ending event here. But yeah, the stakes are pretty high here for backups and restoring. Now, maybe super briefly, go over my backup solution here for the last 10 years. You know, maybe your story is very similar. It's a really common setup, right? Dump and gzip your database every day here to a volume-mounted disk, or maybe an S3 bucket here. And that's the use case we're going to cover here before we start looking at Plakar here. So yeah, you know, basically on the server where Postgres is running in Docker, I'd wire up a couple of different things here. And we're going to go over the script here. We're going to be running all sorts of different things, checking things out in real time. But yeah, this is kind of just like, you know, some notes here that could be interesting to know about. I am going to be using this little example Dockerized web app here. It's available on GitHub here if you want to go and check it out here. But again, this is not related to this project at all. It's just something that happens to have web application with a database, etc. But really the only takeaway here or expectation on your end is if you want to follow along, just have a project that has a database where, you know, you can add some rows to a table here. In my case here, all I did was take this project here, cloned it down, and then I slightly extended it to log all web requests here to a database table. You know, going back to here, you know, if we go and check it out, this is the project here. If we take a look here at some of the diffs, you know, not really important to go over anything really, but yeah, I just basically just added a little Flask middleware here to log all the different requests here to a database table. And then over here somewhere in the models, I just added a little table here. Yeah, logs all sorts of different things like the request ID and IP address. Again, just something little fun for the video, not super important here. But yeah, only expectation, again, you've run something like a compose up here, the project is running, and that's what I have here. I'm gonna actually reload this page a couple of different times here so we can see some data in the database. Cool, but that's it. But yeah, now let's go over this little PG backup script. And again, you know, this blog post, if you happen to be reading that, you know, that is kind of related to running all this stuff on your server, but you can run this on your dev box too if you want to go and play around with things. That's actually what I'm doing here. You know, I'm on my Linux desktop here. But yeah, let's go and take a look here at that script and, you know, kind of go and check it out in detail. So this script, you know, these scripts here that you see, they're not going to be included with that project here. So yeah, this is your PG backup script. Again, I'm using MySQL, whatever, you can name these things different, change around some commands, no big deal. But yeah, you can call the script in a couple of different ways. So for example, PG backup, and then the first argument here is going to be the project name, because you can imagine on your server, you know, maybe you want to have kind of a generic solution where you can pass in different projects to back up and, you know, it's going to name these files based on that project basically. And there's two ways to really use this backup script. One, you can just run it like this with just passing in the project name, and that's going to produce your gzipped database backup in a certain directory. And, you know, let's say you run this every day, right, in a cron job, which we're going to go over in a bit here. But every day it's going to recreate the same file on disk, right? It's going to be overwriting the previous day's backup. And that could be fine depending on your use case. But you can also optionally, if you want, pass in the second flag here, -- today. And when you do that, it is going to set a date here. So if we go and run this command here in a terminal, we can go and check out what the output of that's going to be, which would be year, month, day, right, for the current day. So the idea here there is, when it comes to setting up the backup file, if we happen to have a date here that's, a non-empty value, something like this, then that's going to be appended to the project name, like hello dash and whatever happens to be here, year, month, day. This way, you can have maybe a bit more of a robust backup schedule where maybe you do want to keep something like the last 7 days of your backup. So you can have, 7 of those with their individual file names that are dated for the specific day. And then you can set up another cron job to maybe delete the old backups. Again, we're going to get to that pretty soon here. So yeah, going back to the script here, before we get down to the gory details of everything, the first thing we need to decide is like, well, where do we want to back up these files to? So in this case here, maybe in your home directory, you can have a DB backups. It's really up to you. It's, again, on your server, on your dev box, you can make a path that exists basically. Then the backup file, right? That's going to assemble the project name, etc. And then we have this little temp file here, which we're going to get to in a second here. Let's ignore trapped for last here. But yeah, the very first thing we want to do, right? Just make sure this backup path exists, right? You want to be able to run this script. It's going to create the directory if it doesn't exist. If it already exists, no problem. It's going to skip recreating it because it already exists. But then here, and now the fun part, basically this one line. This is where we're just going to docker compose exec into the Postgres service. And, using this example application that I have here, if we go and take a look here at docker compose ps here, now, here's a list of all the different services that are running, right? We have something like Tailwind and ESBuild and Postgres and Redis, and we have Unicorn for the web, and then also Celery for the worker here. But if we go and take a look here at the compose.yaml file, this might be something you need to change on your end. So for example, in the list of services here in the compose file, we have Postgres and Redis and all sorts of different things. It's really important that that name there in the compose exec command from the script matches up to the service name here. Maybe on your machine, on your project or whatever, that's named databases or DB or MySQL or something like that. So going back to the script here, you want to make a little change there to be whatever it happens to be here. And in this case here, it's going to be Postgres. So we're going to be running a pg dump all. Standard command, not related to Docker. This is just a Postgres binary that's included that allows you to dump your entire database. And it's going to expect that you pass in a couple of different arguments here. So the connection parameters, basically, it's going to default to things like localhost, which means we don't need a password. That's just how things are set up if you're using the official Docker Postgres image, which we are. But we do need to pass in the username. Now, for the sake of this project, the project name that I'm going to pass in here happens to align with the actual username of the database. So if that's different on your end here, just make sure that your project name ends up being your database username. If you need to make a second argument here in the script to support that or whatever you want to do, you could totally do that, right? These are scripts that you can modify. But I just want to show you, if you're using the official Postgres image from the Docker Hub, you can set things like the Postgres user and the password. That's how I have things set up here. So my project name is going to end up being hello here. So going back to the script here, that's all that. And then we're going to take that entire pg dump here, pipe it over to gzip. Gzip is going to compress that in a really nice way. We might save over 50%, file size could be reduced by that just from gzip alone compression. Cool. And then we're going to redirect that to the temp file here. Now, before we go any further, could be kind of interesting maybe to run some of these commands here manually and just see the outputs of them. So let's do that. I'm going to go into a little clearer terminal here, pop in hello here because, we don't have access to that project variable in my shell here. But yeah, I'm going to run that and we would expect to see a dump of the entire database. You can see here the dump has been complete and we are good to go here. If we scroll up here, you can start seeing some of the stuff that we have here. There's a couple of different requests here that were logged when I reload the page a few times here, which is pretty cool. This is everything we need to basically recreate our database when we get to restoring it. So that's pretty nice here. So yeah, then it's going to pipe it into gzip. So I guess technically we can run that. Why not? Although the output of gzip is going to be something we can't really comprehend anyways. Actually, funny enough, I guess gzip even is like, well, I'm not going to even bother writing that to the terminal. However, if you want to see it just for fun here, you can do -f here and we can see like, oh, there it is. Cool. It's like, well, we can't really make sense of that here. But, this is your compressed data here in gzip's format. We don't need to add the -f flag here because we are redirecting that to the file. It's not going to be, terminal output. But yeah, we are going to redirect this to a new file, the temp backup file. And the reason we're operating on a temp file here, notice that .tmp extension, this could be anything by the way, but it is important to have this on at least the same drive as the real location that you want here. I've done videos about that one in the past here, but in the, TLDR for now is, if this command were to partially dump your database and fail, even with error exit and pyfail here, we could get to the point where we end up having a partial backup file. And you can imagine if you ran the script like this without -- today, right, you're going to be overwriting your existing backup. If this were to, somehow partially fail midway, let's say last night or something like that, then your previous backup file that was possibly complete is now going to be corrupted. And again, a lot of things would need to go wrong at once, but if just so happens now maybe something happens where you need to restore from that backup and it's been partially corrupt, it's like you lost your data and that's a big problem. So to get around that, what we could do here is just, redirect it out to a temp file. And then if we get to this point in the file because of error exit, we can be guaranteed that the file has been successfully dumped, it's been gzipped, it's good to go, it's not partial. Then we're just going to move the temp file over to its, final destination here, which is what we want here. And this is going to be an atomic move, which will give us some guarantees here. This file is not going to be corrupt. But again, that's only going to be guaranteed if both the temp file and the real file here are on the same drive. So, that's why I'm doing it relative to this backup path here. It's not going to be in like a temp directory or something like that. That other video I made around this goes into more details, but I think that's enough detail for now. And then finally, lastly here, this trap command here is just going to, make sure that the temp file happens to be always removed if this script happens to fail along the way. We don't just want a lingering temp file there. So yeah, this just traps anything here, any exit. If then, we just have a cleanup there. It's a little bit better putting it here instead of all the way on the bottom there in case, this fails at different points in the script. So again, that's going to always delete the temp file short of like, something where the hard power gets cut midway in the script, right? There's no way the trap command would even get a chance to run. But, that's going to take care of that. So yeah, we have the whole backup script here, blah, 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 backup strategy today. We did all that. Cool. So now maybe we can go over using S3 instead. But before we get to that point, and by the way, we're not going to really be demoing this specifically here, but no worries. We'll go over how to set up S3 a little bit more in detail later when we're dealing with Plakar. But, maybe now would be actually a nice time just to be able to run this PG backup script so we can see what's actually happening here. So let's go and run the PG backup script here, PG backup. And then in this case here, I'm going to pop in hello. That's going to be my project name. Again, that's going to be your database username or project, however you want to label that one there. So let's run this here. Cool. And then we could do an LSLA here on the DB backups directory that we have here. And then we can see there it is, hello SQL.gzip. So everything works successfully here. And that is pretty cool. We can also just try it with the today flag if you want to see what happens here. So let's do that. Nice. And then we can do the same command here. And here you can see the file has been saved with the date for today. Of course, this value is going to be different depending on when you run this one. So what we could do here is I'm just going to delete that file. Not a big deal to delete it, but I just want to delete it for the heck of it. There it goes. Boom. And now we can just do LSLA and there's only the one file there. So that demonstrates being able to run it manually and things are working nicely. But now let's go over, maybe go a little bit over briefly how you can modify the script to use S3 instead. Now, what's really nice here is when it comes to the S3 here, we can actually get rid of that temp file and then the move operation there because we can just pipe gzip straight into AWS CLI here and just copy standard in, which is going to be the output of gzip here, to your bucket. Now, this is a little bit hand wavy. We're not going to demo all the stuff here when it comes to setting this up here, but no worries. A little bit later on when we're dealing with Plakar, we will go over setting up a bucket and some other things. But yeah, okay. So with that said, you would modify your bucket goes here with whatever bucket that you created. And then you would log into the AWS CLI here with your credentials, and then that's going to end up creating this file on disk here, and that's fine. And as mentioned a second ago, we'll go over setting up a bucket and some secret keys here that would be these credentials here a little bit later in this post. But okay, we have the backup file, the script, we ran it manually, it's working well. Now it's time to actually automate the backup. So there's of course a number of different ways. You can use systemd timers, cron jobs, etc. Let's just keep it simple and use a daily cron job here. I'm not going to demo this one here on video just because I'm not running this all on a server now, but this stuff will certainly work. So the idea here, with this script here is I have a deploy user on the server. So keep that in mind. If you want to name this user something different, then you need to make this change throughout the blog post here. And then also, on your server, the expectation there is you've run something like a Docker compose up-d or detach here. It's running in the background there, ready to go. And then, when it comes to the cron job file itself, you need to pick like whatever time makes sense for you. Like what interval do you want the script to run at? In my case here, I just picked 6. And on my servers, I like to keep my time zone set to UTC here. So in this file here in etc cron d, you can just name this file whatever you'd like. I like to keep it descriptive based on what it is. So yeah, it's a PG backup for the hello project here. And then this would be the contents of that file. So it's going to happen at 6 every single day. As a deploy user, what's it going to do? It is going to run this command here, the full path to where the file is. And then, the project name that we passed in before in the command line is going to be put here as well. So basically, we just ran that on the command line, but we do need to pass in the full path here for the cron job because certain things, environment variables like your path won't be available. In this case, yeah, hello is a project. Of course, change that to be whatever you need it to be. So not bad so far, right? We have daily backups running that overwrite each other every single day. But maybe you want to have dash dash today instead. So you have these daily backups, and then maybe you want to keep, let's say, a week of them. Really, it's your call. It could be 3 days, 2 weeks, whatever you want. But if we do that, though, yeah, we're going to have this never-ending disk space, right? Because it's going to create one today and tomorrow and so on, and you're going to end up with all the files there, and then maybe your hard drive is going to run out of space here because, these are not being rotated or cleaned up. So what we could do to remedy that is have a second cron job get created here, in this path here. Maybe we can name this one something like delete old DB backups, which is a descriptive name here. And all that's going to do is run a little bit later than the dump itself, 2 hours later, give some time for your dump to complete, although technically it's not a big deal if that weren't the case here. Still going to run it as a deploy user. And now we're going to run the find command. And we're going to say, okay, so in this directory here, again, this is your backup directory path, right? Adjusted as needed for you in case you change these things. We're going to look for all files with this pattern here. So basically all the gzipped backup files. Then we're going to look for files that are older than 7 days, that m time, plus 7 there. And then we're just going to delete those files. So this is a really nice little one-liner with find to delete files older than 7 days. It takes some extra precautions here to only delete those gzipped SQL dumps here. You could further restrict it if you really wanted to by using this instead for only deleting the hello project there. But on your server, you might have a whole bunch of different projects running, and maybe you want to clean up all of your old backups there in one shot here with one cron job instead of having multiple cron jobs at different, patterns here. But again, choice is yours there. But yeah, I kind of like having the one cron job, clean up all the different gzipped backup files there. And if you're using S3 though, instead of local files, then you wouldn't need this here, right? Because these files aren't going to be saved on disk. They're going to be saved to S3 instead. In which case, you need to set an S3 lifecycle policy to delete those objects older than 7 days. So here's some instructions on how to do that here. Actually, it wouldn't hurt, I guess, to show that on video, because if you've never really set that up before, it could be maybe a little confusing, I guess. So let me go to, I don't know, let's say S3, and we'll go and check that out. Because I already have the bucket created that we're going to demo a little bit later. But yeah, here's the bucket that I have here. So you would end up going to management here, and then lifecycle configuration, lifecycle rules. You can create your rule here. I'm not going to really name it anything, whatever, because I'm going to delete it anyways. Here you can make a decision, like, do you want to limit the scope to a certain subset of objects in the bucket, or do you just want to apply to all the bucket, or apply to all the objects in the bucket? So in my case here, I'm going to choose apply to all objects because, this bucket here, Plakar backup data, it only has database backups here. In my case here, I'm going to be happy with that. Although, funny enough, like, this wouldn't be the bucket you want to have this lifecycle rule on. Later on, we're going to show that we'd want to delete this because Plakar is going to handle all that. But I just happen to have a single bucket in my account here, so I'm just demoing it for you for the sake of that. But in any case here, lifecycle rule actions, going back to the blog post, expire current versions of objects. So expire current versions of objects. Notice here when I click that, this little section here comes up. So we want to go there. We want to say 7 days. Again, if you want to have 3 days, 2 weeks, 14 days, like whatever you want there, you can do that. And then secondly, delete expired object delete markers. Okay, let's go there. Delete expired object delete markers or incomplete multi-part uploads as well. We want to check that. And when we do that, then this is going to pop up here. And in this case here, we actually want to delete incomplete multi-part uploads, and maybe we'll just say 1 day there. So the idea here is, if a partial update were to occur, that wouldn't create a real file, but it does create this, I don't know how you want to label this one, some multi-part upload file here will be deleted here. So we want to have that extra cleanup there in case our database backup fails. So that's all that said, really. I'll probably add a third bullet right before just to, maybe do the call out here for applying it to all objects in the bucket if you want. But yeah, once you have all that set up, you can go and create this lifecycle policy here. So it's going to let you know here on the bottom here, hey, by the way, objects that are uploaded after 7 days, they're going to expire. Expire is basically a term for saying deleted. But yeah, there's all sorts of different things you can do extra, but that's not really related to this post here, different capabilities of S3. But yeah, now we have that one lifecycle rule here. Things are going to expire after 7 days and we're good to go. Cool, permanently delete. But in this case here, I'm actually going to delete that here because I don't want it set to this bucket. Yep, I understand. Thanks. Cool. And we're done. So that takes care of backups, right? We have a solution where we can run it manually, a little shell script on our server. We can run it in a cron job. We also have the pruning set up here for deleting backups older than 7 days because we want to keep just the first 7 days of backups. But now it's like really important to be able to restore your data as well. So being able to restore, again, second piece of the puzzle here. If you have a fresh database, then what we could do is wipe the entire database. Don't just blindly run this on your server, by the way. This -v is going to delete your volume, so your Postgres data is going to get wiped. But on the dev box, we're just playing around, or maybe this is what you want to do on your server, again, being very careful, we are going to be able to restore from that database backup we just took. So with that said, we can go and wipe our database here and then do the restore. So let's actually do the restore first, and then we'll go and check out the script. So let's go and see how that's going to work. So what we could do here is, we can do our downed v, right? We took a look at the database output before in PSQL. So now let's go and kill this out here. I'll also get rid of that second one. Then we can do docker compose down v. Completely wipe database at this point. So if I were to do compose up now, it's going to recreate a complete fresh database here. That's just how the Postgres image works. We can see the orange text here. It's doing all sorts of different Postgres-y things here, creating a completely empty database. And if we were to go here and, run PSQL now, and we were to go and try to even do like a select star from request logs, it doesn't even exist. Like this table doesn't exist, right? And if we go back to the code here, if we go to models.py, we had that little request logs table here. That table does not exist. Why? We wiped the database entirely. And I didn't even run the normal command I would do here to reset the database by creating like empty tables that wouldn't have any data. So we had the database up and running. Cool. So now we can actually restore the database from the backup. So what we could do here is pg restore. And then do we need to type in the project name? I believe so, but let's keep myself honest here. pg restore. And then, yeah, you just restore from the actual project name. Or if you're doing the year, month, day option, you don't need to add a little dash before. You can just pop in the day that you want to restore from. Because you can imagine, maybe you want to restore from 3 days ago. So then you would put in, this pattern here for 3 days ago. But let's just do that because, again, before I even run that, if we go and take a look here, we have that one file there. So let's do a pg restore on hello. And this output's normal, a lot of things going on, no worries. But this just, and again, like this role hello already exists because the Postgres database, geez, I feel like something's crawling on my neck. Sorry, it wasn't, I don't think. But in any case here, the hello role already exists here. That's fine because, Postgres official image already sets it up for us. So that got skipped. But all of our data here should be good to go here. If we actually go and run a PSQL, then we can go and take a look here at, we can just rerun this one here. Select star from request logs. There's our 3 requests from before. It looks a little bit hard to read on video maybe because it's all wrapping around, but that's our database restored successfully from our backup, which is awesome. So now let's go back to the script itself and kind of just go over how this little restore script works. So very similar patterns to the other one, right? We could pass in a project name, an optional date. If we actually do have the date passed in, right, this variable is not empty, then we're going to set that date to the date that you pass in. Then, we need to define where our backup path was before. Again, you want to change this if needed here, right, based on your path. And then, there's a gzip file here. And then we have the one command here, which is going to unzip our gzipped file here. That's going to produce the uncompressed file. And then it's going to pipe it straight into the PSQL command here. And then we're going to pop in the username just like before for the project. Again, Postgres service, etc. Feel free to modify that as needed. But if we were to actually run this unzip command here manually on our terminal, just so we can see what's going to happen here. And then we can do the path on DB backups. And then that's going to be hello here. We could see, there is the plain text uncompressed version that's being piped into PSQL here. And then PSQL can totally accept that, for standard in here. That's why we're using no TTY, by the way. And then, cool. So now we have our database restored. So going back to the blog post, nothing new to really go over here. Yep. But this is a pretty inefficient approach in general, right? The way we're doing the backups and restoring, right? Because every day you're doing a full SQL dump here. And while it does use compression to save costs there, you are transferring the entire gzipped SQL file to S3 every single day, even if your database maybe only changes 1% of your data between each day, right? Maybe you have a SaaS application and maybe you have, I don't know, whatever, like 78 new users signed up yesterday and then 100 new users signed up tomorrow or something. But in this case here with the full dump, you're dumping everything from the beginning of time to right now every single day here. And again, if you're not using S3, then, just replace that with local file storage, like, your disk space or whatever. But yeah, depending on what you're saving in your database, how much database you have, that could be anywhere from, right, a couple hundred megs, maybe a couple gigs, but there's no limit, right? Maybe your database is 2 terabytes, and doing that every day would be kind of a lot here. But yeah, what about incremental backups? Because, if you're using a modern version of Postgres, 17 or above, it does support this idea of incremental backups. And we're not going to go over that in this video here. It's really thorough, and it's actually a little bit complicated to set up, especially when it comes to restoring. But there are tools like PG-back arrest here, open source tool, that you may want to check out if you care about like point-in-time recovery and stuff like that here. This tool makes that a little bit easier to set up here. Maybe I'll cover that detail in another time here. Let me know in the comments here. It's not really time or place for this post here. But yeah, personally, daily backups with a means to restore has gone a really, really long ways for me in a lot of different projects for both myself and clients who had, millions upon millions, tens of millions of rows. Some of these clients had tens of millions of dollars. So it's like you can do daily backups and restore and be completely fine. But again, that's a risk, right? If you need point-in-time recovery to be like, hey, you know what? I want to restore my database from, 8 minutes ago or something like that, then checking something like this out could be interesting. But yeah, let's go into maybe some of the benefits of Plakar, because for daily backups, it's very, very useful here. In my opinion, the biggest win here is how it dedupes your data between backups. So you only have to send what changes each day, and Plakar handles internally how to do that. So you can be like, hey, by the way, give me the latest snapshot, or maybe give me the latest snapshot from 3 days ago. It also produces a file that you can restore your database from. So conceptually, the strategies we use now to do backup and restoring is going to be pretty similar with Plakar. We're just going to change around a couple of different commands here. But let's go over a concrete example, right? Before and after. Maybe how is it going to save us money? Something like that, right? So concrete example, right? Something to work with. So let's say that you want to keep a week's worth of backups, right? You pass in that -- today flag here. You're going to keep 7 days in S3. And then, yeah, when estimating costs, we'll do this with and without Plakar. So let's say that your gzipped database dump is 10 gigs in size, and every day you add roughly 100 megs of new gzip compressed data, right? Basically 1% growth per day here. And if you only wanted to keep, let's say, 1 day's worth of backups instead of, 7 with -- today, Plakar still adds a lot of value here because you'll soon see how Plakar lets you perform incremental backups without needing to transfer the entire dump every day. So even if you're recreating that dump every day, you'd still have to transfer the whole thing. Plakar is going to do that in a way that you wouldn't have to. So keep that in mind when it comes to the data transfer costs here. So without Plakar, let's go over how much data would be dumped and sent over the wire to S3 over the internet. So on day 1, that's going to be 10 gigs. Day 2 is going to be 10 gigs and 1% more. And then day 3 is going to be 10 gigs and 1% more of this one, and so on, right? Until eventually we hit day 7, which is going to be this here. So at the end of those 7 days here, 72 gigs and change would have been sent and stored. So now let's say this continues on for about a year. And over the year, you have a successful business and your database is growing from 1% to 2%, but it's doing it in a linear fashion because, yeah, maybe your business is predictably growing a little bit. And by the end of the year there, you now have 2% growth. So here's a couple of numbers from that. So by day 90, you're already sending over 20 gigs per day. By half a year, you're at 32 gigs. 3/4 of the year, almost 47. And then by the end of the year here, you're at 65 gigs. But we started with 10 gigs here. So that's actually a really crazy exponential growth here, even from a linear increase here. But in any case here, that's climbing really fast. And if you summed up all the data sent over the course of a year to S3, you'd be talking about somewhere around 12.5 terabytes here. Now, thankfully, sending data into S3 is free, so we don't have to pay for that. But if you've ever used S3 and, when it comes to, hey, I want to get my data out of S3, then it's like, they really sink you there with some of the costs there. But, if you are sending data from your cloud provider into S3, let's say maybe you're using a different cloud provider, then they might have outgoing data transfer fees just like general purpose, right, to the internet, whether it's S3 or something else here. So that's a lot of data to be mindful of there. So by the way, I mentioned S3 a few times here. I don't think I mentioned this, but Plakar will work with anything that is S3 compatible. So if you're using Backblaze or DigitalOcean Spaces, then you're good to go there because it's not really using the AWS CLI behind the scenes. It's using the API. But in any case here, going back to here, if you're on AWS and your EC2 instances in the same region, it will be free, but be careful if you have a NAT gateway associated to that instance because you'll certainly want to set up an S3 gateway endpoint for that one to avoid NAT NAT gateway fees here, which would be a lot, right? It's almost 5 cents per gig there. So year one alone, it would be over $500 and change here to transfer over that 12.5 terabytes if you didn't do that step. If you did do the step, then actually it would be free. But now going back to the end of year one, right? That's going to be around $10 a month in storage cost alone. And that doesn't seem too bad, but it's a bill and it's going to keep on adding up here because, that's based on basically a half a terabyte here. And there, the way we got to this one is by the end of 1 year, we have about 65 gigs, I'm kind of rounding up a little bit. And then you do times 7 here, and that's how you get that. So that's a rolling 7-day fashion there. And yeah, that's also using the S3 standard rates, which is this price here on, something like US East 2. So yeah, that's a little over $10 here. And by the way, we're using S3 standard here instead of something maybe like infrequent access or glacier options here, because those typically require a minimum number of days to pay storage on, such as maybe 30 to 90 days there. And that kind of conflicts with our 7-day amount, right? We'd have to store it for much, much longer than we actually want here. So standard ends up being a better deal here for this specific use case. But again, depending on what you're doing, that may vary here. Also when it comes to some of these options here, besides standard, there's a little bit of a long retrieval time here. But if you need to restore your production data, usually it's like, hey, I need that right now, not like 24 hours from now. And by the way, as an aside here, if you were saving your backups on disk instead of S3, then yeah, after those 7 days there, you'd have a half a terabyte of disk space. So you would need that amount of disk space there. So even if you're not using S3, you need to keep that in control there, which will also have its own costs associated with it on most cloud providers, or, you'd have to buy your own hardware and, yeah, be upgrading that pretty frequently. So long story short, year one is only the beginning, right? It doesn't seem too bad to begin with, but over time, sending everything over the wire, saving full copies of everything is going to add up quite a bit here. And our database is not even that big either, right? 10 gigabytes. What if it's like 10 times the data? Then your costs are going to increase 10 times as well, usually. So now let's go over Plakar, right? Its dedupe feature alone will save us a lot here, but it does a lot more than deduping. So Plakar is built on top of an immutable data storage engine called Closet, which is over here. You can go and read the details here. We're not going to go over that in the video, but if you're interested, it's there. But the TLDR for now is your data basically is going to get split up into chunks that is internally managed by Plakar. This could be database dumps, it could be binary files, it could be whatever files that you want to have, right? Whatever happens to be. It has a deduplication feature that's going to scan for these chunks that already exist. So behind the scenes, it knows to only add new chunks that don't already exist. And by the way, this is really important, but we've been manually gzipping our dump without Plakar, but when we actually use Plakar, we won't gzip it. Instead, Plakar is going to handle deduping and compressing those chunks internally, so it manages all that complexity for us. So with that said, the numbers below that we're about to see, they still assume things are going to be compressed because they will be compressed in the end. Now, when it comes to using Plakar here, every single time you take a database backup, such as a daily backup, you are really taking a Plakar snapshot. So these snapshots end up being standalone backups that contain those deduped chunks. They're not incremental that need to be replayed in order, like a traditional incremental backup solution there. You can even perform a diff between these snapshots that are really cool. For example, maybe, we saw that data before where we had a couple of different requests that I did. We can end up seeing the actual diff if I were to reload the page a couple more times. And we're going to see that pretty soon once we start actually getting back to running real things here. But we'll still take a daily database backup, but instead of them being gzipped and sent to S3 independently, we'll end up creating a Plakar snapshot here and tell Plakar to use S3 as its backend repository. There's other options too, which we're going to go over in a bit. But here's our example from before, our 1% growth that's going to go linearly over to 2% here. Now, using Plakar, maybe in fact, we'll go back up here real quick just to show what this was before, right? This is without Plakar. Every day we need to send the full thing here, and it's going to grow over time, right? Because our database is growing. At the end of 7 days, 72 gigs would have been sent, and there it is. But going back to using Plakar here, again, we only need to send those diffs here. So the first day one, right, our initial 10 gigs need to be transferred, right? Because that's the entire database. But look at day two. Day two is like, well, you had 1% growth, 100 new megs. That's the only thing that needs to change. And then day three is going to be like, well, 1% of that, and then that, and then that. So it's like by the end here, we only need to transfer a little bit over 10.5 gigs, right? 10.6 there to be exact there over the wire, compared to 72 gigs without Plakar. So right away, it's like, that's a massive savings there of just like, efficiency, right? Now, when it comes to our numbers here for the course of the year, look at this, like after 90 days in, it's barely gone up. Even after an entire year, it's like, okay, cool, there's like 200 megs, nice. It's like, if you sum up all that data now for the course of the year, you're only sending the size of your database in the end, which is going to be about 65 gigs. Compare that to the 12.5 terabytes that you would have done without Plakar. So, if your hosting provider charges outgoing data transfer fees, this is really only a tiny fraction here. And, with that EC2 NAT gateway example, instead of the 500 and change whatever per year, it's going to be $3. Although honestly, in this case, I kind of would classify both as zero because you can totally mitigate this pricing here just by setting something up on AWS. But again, you need to go and set that up on your own there. At the end of the year here, our database is still about 64 or 65 gigs in size here. But with the same S3 strategy as above, our cost is only going to be $1.50 a month instead of $10 there because of that deduplication by itself, which is awesome. And we also only need to store those 65 gigs instead of 7 full dumps there, which would be half a terabyte. That's how we get to this price difference here. Same goes available for disk space here if we weren't using S3. And again, don't need to say this, but as time goes on, you save more and more. It's kind of like a snowball effect in savings, right? Think about retirement investing, right? Compound interest, it's really hard to visualize even with linear growth, right? If you have $100,000, right, and you put $100 a month in for 40 years, you're going to end up with over $5 million at 10% interest. So that's a really big number from just putting a little bit in over time. And this is kind of the same thing, but sort of weirdly in reverse, right? Deduplication is similar, except it applies to disk space in reverse, and that's a good thing. So what about using your hosting provider's backups instead? So we've been talking mostly about self-hosted databases now, running Postgres in a Docker container, or maybe not, if you want to adjust those commands there. But, let's say that you're using something different. What if you decided to use a managed database on some cloud hosting provider, right? For example, on AWS, you might be using RDS, which is their hosted database solution there for SQL databases there. It has a snapshot feature that you can do to handle backups and restoring with automated snapshots. Other cloud hosting providers have similar solutions there. Now, when it comes to the AWS model for calculating exact costs for automated snapshots, that's a little bit hard to calculate ahead of time here, but it will be quite a bit more than just saving things to S3. And while they are incremental, they are not deduped, which means if you have something like a staging and production database with similar data, you're going to be paying for both there. Whereas Plakar, if we use the same repository there, then it can even dedupe things between environments there or different databases, which is pretty interesting. Now, when it comes to the automated RDS snapshots here, those backups, those are not going to be portable. That's locked into AWS. Whereas with our self-hosted solution here, we're just dumping Postgres and then restoring. It doesn't really matter, what hosting provider you happen to be using because, Postgres is fully managed by us. Now, with that said, unless you plan on moving across different cloud providers, maybe that's not an issue. With that said, though, there are some benefits of using the automated backup solution on AWS, right? Because it does offer point-in-time recovery. If you want to say like, hey, I want to back up from 20 minutes ago, you can totally do that in a couple of clicks of a button there. So you are getting that benefit, but you're paying a higher cost there. So, these are trade-offs that you'll want to consider. But yeah, going back to our self-hosted database setup here, let's go over doing all this with Plakar now. So first things first, we would need to install Plakar. There's all sorts of different ways to install that, depending on what operating system you have. There are AMD and ARM64 binaries for macOS, as well as Linux and Windows. So if we go and check this out here, you can go and download whatever makes sense for you here. So yeah, you can see there's all sorts of different things here. Yeah, there they are. So, but in our case here, we have a couple of different options, high level, right? If you're on Windows, I would suggest using WSL2 here, since we're going to be running shell scripts if you want to follow along. If you want to use a package manager, sure. If you're on macOS, you can just brew install Plakar. You're good to go. Get the latest version there. On Arch, you can do the same thing. However, this depends on the AUR, so you can use Yay or Paro or whatever AUR helper you might have. Or if you want to go and download the package yourself, you can totally do that. It's up to you. Or you can just curl down a binary, which is what we're going to do here on video. But again, doesn't really matter how you have this installed. On other distros here, that happen to use apt or DNF, you can find some steps here. So you could just install those packages as well by following these instructions. Again, this is really up to you on how you want to have things set up for the installation. Now, with that said here, I'm going to be targeting version 1.14 for this post. Just happens to be the latest version at this period of time. If you're watching this post in the future, feel free to get a newer version here. More than welcome to use it. Hopefully there's no backwards incompatibilities, but if there are, maybe minor little things will change, and I'll do my best here to keep things up to date here if stuff breaks in the future. So what did I do? Well, I like to use Debian in production, so I've installed Plakar's Debian package on my server, basically following this here, all set up through Ansible, but that's a little bit out of scope for this video here. But with that said, on my dev box, which is using Arch Linux here, I just downloaded the binary directly here with curl. So this will work on Windows 2 as well with WSL2. Feel free to adjust to AMD 64 with ARM 64. If you have an ARM-based CPU here, that would be this here if you want to make an adjustment there. So when it comes to just curling it down, feel free to copy paste either one of these solutions here. This one uses sudo because it's going to ultimately take this compressed file here, uncompress it to user local bin, which is something that will require sudo on most systems here. The file name in the end is going to be Plakar. If you know that you have something like .local bin on your system path here, then you can do this without sudo. Again, we're not going to be using sudo to run anything. This is just downloading it. Now, I will say I did forget to put one thing here in the blog post. I'll make an update for that later, but you do need to chmod +x this file here. So let's say it's in user local bin. I believe that's where I put it on my system. Let me go and check that one out. Going over here. So in which case here, I'll just do which Plakar here. We'll take a look at where it is. Yeah, there it is. Okay, so it's in local bin. So I'll just, you'll want to do this, right? chmod, and then wherever you decide to put it, there it is, and boom. Mine was already set like that, but yeah, I'll add that to the blog post, not a big deal. But then from here, you want to make sure that you can just do Plakar version. This should give you back some version here. It doesn't really need to align here. If you're watching this in the future, maybe it's a little bit more modern. That's totally fine here. Basically a sanity check. So no matter how you installed Plakar, at this point in time, you should be able to run this version command successfully. So now let's go over daily backups with Plakar. So earlier we covered how to do it without that. And honestly, our strategy is not going to change that much. Of course, we will be tweaking a couple of things here, like running different commands, but it's going to be the same general idea. Create a database dump on a daily cron job. Plakar stuff is going to happen, and then the database gets saved to either local or network mounted file system or S3. And now if you don't want to use S3, maybe you want to use something different, it supports all sorts of different things. File system, S3, Google Cloud Storage, Azure, SFTP, Dropbox, Google Drive, OneDrive. There's all sorts of different destinations here that you can go and check out on your own here, which is pretty interesting. So a lot of options there. But yeah, let's go over first dealing with local backups, right? Just like we did before, we're going to have this be saved to the local file system. Then we're going to migrate things over to using S3. So before we use S3, yeah, let's experiment with local storage first. Technically, we're going to be creating a thing called a Plakar repository. And yeah, along the way, this is going to be basically a crash course in using a Plakar. Let me get rid of that. Sure. So we only need to run this once here. So we could basically say, you know what, this is where we want our Plakar repository to be. Feel free to modify this. Although, if you do modify this, then you're going to have to modify it in a couple different scripts and throughout this post with some of the commands here. So let's do that. All right, I'm going to do this. Cool. And then it's going to ask us to put in a repository passphrase. I'm just going to do like hello at world 1 2 3 4 5 bang. Feel free to use a more secure password. It's really important though, because Plakar is going to encrypt your data with this password. I didn't mention that before, but besides deduping, it's going to encrypt and decrypt your data. So, carefully save the passphrase that you're going to use. Again, if you're screwing around on your dev box to practice, no worries. But when you're doing this for real, yeah, anybody with this passphrase can decrypt your data. Also, if you lose it, then you're done. You've lost your data. So yeah, put this in a very, very, very solid spot that is not going to get lost. There we go. I'm going to put in my password here, confirm it. Good to go. Oh, interesting. So this directory needs to be empty. So let me go and delete this there. There we go. And then we can rerun this one. There we go. That should work. And if you put in a password that's not secure, then Plakar is going to warn you of that. So yeah, okay, cool. So now we have our repository created here. I'll make sure to add a note here to rm the old directory first. So now let's go and maybe check out that backup directory. Sweet. Let's go and check out to see how that changed. I'll give some more room here as well. We can see all sorts of different Plakar related files here. You can see we didn't create these by hand. It did for us. That's good sign. Cool. So, but now we have a place to back our database up to, but nothing has been backed up yet. However, before we start going into different scripts and things, it would be kind of nice to introduce a Plakar alias here. Basically, when we run all sorts of different Plakar commands, we're going to end up passing in this argument here. And, if you change this path to be something else, it would be a little bit annoying to need to go back to all your different scripts, all your different commands, whatever, and just modify this here. So we can create an alias that is going to point to this path in a Plakar configuration file, and then we can just reference the alias instead, which is pretty nice. So, again, this makes things a little bit more portable here. We don't need to like jump into cron jobs and change paths if we decide to change the path later. So for example, we can run this here. We're going to use local as the alias name, but really it can be named anything you want. And in this case here, I'm going to be using $home here as a location, and then DB backups. Again, feel free to modify this here. And again, if you're running this on something like your server, this could end up being like your deploy user. And on your dev box, like this could be Nick or whatever your home environment variable is going to be. So let's go ahead and run that one. By the way, I will mention before we even run it that using tilde here instead of home probably isn't a good idea, at least not at the time of creating this video here, because it's literally going to put that into the config file because it's not going to expand that out to your actual home directory like it would on the shell. So just a heads up there. All right, so we're going to run this here. Cool, so there it is. We can see we are creating a Plakar store. We're going to be adding what? The name is going to be local. There's a location, and there is the path to it. So if we go and take a look here at config Plakar, then we have stores.yaml. We can see there is our little alias here created with local. In the future, if you decide that, maybe I want to change this name to be something else here, then in this config file here, you would go and change that. Although be mindful, if you're referencing that alias in scripts and cron jobs and other things, you'll want to go and update it there as well. But you can see that home environment variable there got, expanded out to my actual home directory here. Cool. All right. So there's that. You can verify it just like we saw before. Nice. So now, instead of running something like Plakar @ and then passing in that path here, we can just do the @ sign there and our alias name. So we're going to see that along the way quite a bit here. So now before we even start running other commands and going into scripts, maybe we can talk a little bit about storing your passphrase. So if you're going to be, kind of messing around temporarily on your dev box, it could be helpful to export this environment variable. This is an environment variable name that aligns with what Plakar expects. So it's looking for a Plakar passphrase. If you don't supply that, then it's going to prompt you to enter your passphrase. But you can imagine, typing that, 20 different times to run 20 different commands would be really annoying. And then also, if you want to have this run on a cron job, that needs to be able to run unattended with without you typing in your passphrase. So on your dev box, you might just want to export this to your current shell so you can run some commands and see that without needing to do that. And if you're on your real server, well, we'll go over this in a second here. Now, I will mention here before we run this on our dev box, you might not want to save this in your shell history. So a lot of shells, if you start your command with a space, then it won't save that to your shell history. So I'm going to do that here. So let's go and run that. I'm actually going to manually hit spacebar and then paste this in here. And, if we now echo out Plakar passphrase, it's there, but it's not saved in my shell history, which is pretty nice here. But yeah, if you're doing this on your real server, and again, you could also do this on your dev box. There's no harm, no foul here. So we already have this config Plakar directory here. What we're going to do here is just create a new file, .env-passphrase. This could be named whatever you want. It could even be in a different path. It's really up to you. I kind of like just having them, side by side in the Plakar config here. That's a personal opinion here. But yeah, we're also going to chmon it to 600. So only your current user can read this file here because, if you have maybe a server with multiple users, you wouldn't want other users being able to see this. So, we can experiment with this one, right? We're just going to echo this out to there. Cool. Again, you can put the space before so it's not in your shell history. And then if we were to go and take a look here at the Plakar here, we have that .env file passphrase, and there it is. So going back to here, it is pretty nice to have this set up here. So now we can just have hands-free Plakar passphrases, so we don't need to keep typing it. Nice. By the way, it's important to export it in the echo statement that we did here. Technically, if you just did this without the export there, then things are not going to work in our shell script because we need to make that environment variable accessible to the Plakar CLI here. Basically, that's a child process within the script. So just a little aside there. But yeah, okay, now we've got this set up nicely. So we have our passphrase all good to go. Cool, so now let's create the script to perform the actual backup. Now, just like before, but now we're gonna use Plakar. So I'm gonna name this script here, pg backup -Plakar. Realistically, if you want, you can keep the original name, but keep that in mind when you follow along here. There's some references here with -Plakar here. But yeah, let's go over that script here. Then we're gonna run it and go and check things out here. So here's the original script here, and then there is the Plakar one. I just wanted to have things set up here where we can look at them, side by side here with different names. So with that said, you can see the usage is a little bit different. So if we actually go back and take a look here at the PG backup script that we took a look at before, you can see, originally we just ran it with the project name or maybe -- today. But now, we're just running it like this, same different file name, whatever. Project name is still going to be there, but the idea of -- today went away because Plakar is going to handle that idea for us there, those incremental backups there, but it's not incremental in the same way you might be thinking. But in this case here, we're going to be passing in an environment variable, which is going to be the Plakar repository. So this is going to be the alias that we just set up before here, at local. This is pretty cool because it means the script is going to be pretty generic, right? If we were to change over to using S3 later, then at call time, when you run the script here, we can just do like at S3 or whatever you want to name it. The script itself actually doesn't change here. So, but looking, before and after, remember the top one is Plakar, bottom one is the original. We're still going to pass in the project name as the first argument here. And the backup file is going to be quite a bit different because if we go back to here, the backup file was going to be, this file that we created on disk. But now, I guess a little bit of a spoiler, it's not a big deal, but it's like, we're just going to take this output here from pgdump. We're going to pipe it straight into Plakar. So we actually don't have a file on disk that we're doing the dump all onto. So when we go and run Plakar here with the backup command and we pass in a backup file, we need to tell it, hey, by the way, this file is actually coming in from standard in. And when we run all sorts of different Plakar commands, we still want to know like what the file name is associated with that, right? There's no file on disk, but here we can be like, okay, we're going to name this the project name.sql because that's the file that we're backing up here, which is, we're going to be able to see some of this stuff in the Plakar outputs. So that's why we have it set up like that. Then we need to deal with the passphrase here. So the idea is, here's the path to where, I save that passphrase here. If you modify this path here, then, modify it in the script as well. But the idea here, and I like using shell check, I've done videos about that in the past. So the idea here is if this variable is empty, -z here on Plakar passphrase, going back to our other terminal before, I actually cleared this one. If we do echo Plakar passphrase, it is output here, and just due to how the shell works, environment variables that are in this shell here, when you call that shell script, the backup one over here, then this environment variable is going to be available here. But if it's not available, then it's going to go in and source this file here, which again, I'll just rerun this one here. If we go to Plakar or env passphrase here, this is this here. And when we run the source command here, it is going to source in this file that we have here, and it's going to make that environment variable accessible to the rest of the script. So in any case here, we're going to end up either reading it from our terminal, or it's going to end up being read from the file here. And if this file path doesn't exist here, and it's also not available here in the environment variable, then this is going to fail because this path won't exist, which is pretty good. We want to exit early here with error exit because we do want a passphrase at this point. We could even go the extra mile here and do the opposite of a -z or maybe a -n check here to make sure we actually have a Plakar passphrase. Then just going back before we wrap this up here with some of the differences, the trap goes away because we don't have a temp file anymore. We don't need to make the backup path here because Plakar is going to guarantee that path will exist before we run this backup command here. But we just take this pgdump command, same exact command as the one that we ran before. You can see I'm selecting that, this is a match there, same string. So piping it into Plakar, we want to say, hey, by the way, this Plakar repository, again, coming in over here, then this is going to be at local or S3 or whatever we decide to name that. Then we're going to run Plakar's backup command on the backup file. And that backup file is going to be coming in from standard in, labeled this way, straight in from pgdump. It's going to be the plain text version of pgdump all here because, we don't want to gzip this one because Plakar is going to handle all the deduplication of the plain text here. And it's also going to compress it using its own internal formats. So let's go and maybe run this command here and check it out. And then we can start playing with some of the Plakar commands. So we could do our, let's go back here to the call signature. Yep, we want to do that. And if you adjusted some of these names, feel free to adjust them. But in this case here, that pg backup Plakar, I should mention here too, is in the current directory here. I did a chmod +x on this file, just like before. For example, chmod +x, just like that. So going back to here, let's run this command here. This is going to perform a backup using Plakar for the hello project here on our local alias that we have set up. So let's do that. And this is actually going to fail here. Why? Because it says blah, 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 no such file configure directory. Let me go and take a look here what was in DB backups. Did I actually delete that? Yeah, I did, because I was playing around with something off video. Not a big deal. Actually, it's maybe not a bad reminder here. Well, what do we need to do? We need to actually create a new repository just like we saw up here. So we're going to do that. Cool. I'm going to copy paste that there. Done. This time around, it didn't ask for the passphrase because that was already exported to my shell. That's pretty cool. We can actually do our LSLA there again and take a look here. Yep, there it is. Nice, nice, nice. We want to set up the alias just like we did before. Yep, going to do that one. Actually, the alias is already still there because I didn't mess around with that file. I don't think, right? No. Let's go and take a look here at stores.yaml. Yeah, there it is here. Now that's a side topic to go over here, right? When it came to this backup repository location, I just rf the directory there. That didn't modify the store at all. So our alias is still there for local. So yeah, now we can go back to where we were before here and then just rerun that command that failed a second ago here, which is going to run the actual backup. All right, let's see what happens here. Nice. So this type of output is what we expect here. This is Plakar performing its backup, letting us know all sorts of different things. This value is going to be different for you. That is going to be randomly generated. It is a snapshot fingerprint ID. So that is pretty cool. So let me just go back to the blog post here, kind of went over the script, blah, blah, blah. Yep, went through all this stuff. Oh, one thing about multiple databases here, it's kind of interesting, right? Because, maybe on your server, you have a couple of different databases such as staging and production, or maybe two completely separate databases. And when it comes to using Plakar there, it is suggested to use one repository there, this DB backups in our script that we're playing around with here at local, but this could also be S3 as well. And the idea there, though, is this lets Plakar do cross-database deduplication, which is a huge win, especially with something like staging and production, where, you might be seeding your staging database off of production. Maybe you do some anonymization there on PII, right? Personally identifiable information there, like people's names, social security numbers, but there could be a lot of same information there that can be deduped if it's all in the same repository. It also reduces operational burden on you because you can use the same passphrase for each database. It also means you only need to run one Plakar specific maintenance command once, which we're going to go into more details later. And, just going back to the call signature there, we ran it like this. If you had a second database that you wanted to back up, you can just pass in a different project name when you run backup Plakar here. Maybe you can do something like hello-production or whatever makes sense to you here. So then we can verify it's created by doing an ls. So we can do Plakar at and then at local ls. Again, if you change this name to be something else, feel free to modify that one. So let's go and check that one out here. Cool, there it is. And then we can run this one. We should see an ID that matches this one here because there is our backup, 8.9 kilobytes here. I will mention here too, you can export this Plakar repository here, at local, and then you don't need to type this for all the different commands. For example, if you were to do export Plakar repository like this, then you could do Plakar ls just like that. That's going to give us the same information here. But I don't know, I'm not a big fan of this one just because I like to be pretty explicit in some of these commands. I like to know that, hey, by the way, these commands that I'm running right now, they're all associated with this repository here. If this were S3 or something else, you don't really know unless, you look at this environment variable when it's not there. So I'm actually going to unset this environment variable there. And if I try to run this again like this, now it's going to be like, well, you can't really do that because you need to supply, some repository to operate against. So going back to here, we can just run our command like this. And then that should work just like it did before. Cool. So there's that. And yeah, maybe now would be a good idea to add some stuff to your database. So I'm going to go here, refresh a couple of times. I'm just slamming refresh as fast as humanly possible, for me at least. And then, yeah, we can run another backup and then another ls, and we should see two of them. So let's run another backup here. All right, going back to the commands that we ran before. We're not going to change anything here. Same exact command as we ran before. And there we go. We can see a different ID this time around. There's the one from there. And if we do an ls here this time, we should see two of them. And the second one should be bigger, right? So the first one, the older one from a couple minutes ago, 8.9 kilobytes, right? And this one is 11 kilobytes here. And we can see we have different IDs here because different snapshots were created. So going back to the blog post here, it's pretty nice here. Yeah, we can even verify these by running check. So let's do that. That's kind of neat. So we could do a check on, FF80 over here. And we can see, yep, okay, cool. There's our name from standard in, right? Hello.sql here. There's no errors. Everything is good to go. It's checking out. We can also do the same thing on the other one if you just wanted to see for fun. There we go. And we could see this one with this ID is the same deal. So that's pretty nice. You can even do more of a deeper check here if you get info. So let's go and take a look at info instead of check. So we could just do which either one, doesn't really matter. So we can go info here and we get a lot more details about this. So if you scroll up a little bit, then, we can get things like the full snapshot ID. In this case here, there's only the first, 8 characters here. Right, 1, 2, 3, 4, 5, 6, 7, 8. But then really that's a pretty big snapshot there. We can see timestamps, how long it took to perform. This is pretty neat too, right? Because maybe you're doing something on a remote server like S3 or Dropbox or some other backend there. It might take a little bit longer, instead of a local file system. And then, yeah, we can see all sorts of different details around the machine that did it, and some summaries there, and yeah, a lot of information, hence the name info, which is pretty cool. What's really nice though is you can even diff these as well. For example, if we go and run this command here, then, let's go back and run the ls command. Then we can run a diff on this. So I'm going to have to change this is going to be the older one. So in this case here, on the bottom of that list there, the 5C1, so 5C16, EC1D. Again, these are going to change for you, right? I'm just reading it from there. And this other one is going to be, instead of this one from the blog post that's older, I'll do the F8011D4. And then, yeah, we need to basically do the syntax here. So we're going to do our normal Plakar command. Yep, we want to this repository. We're going to do a diff instead of ls or check or info. And then the format for this, the left and the right side, is, the snapshot ID, colon, and then the path to the file that you want. In this case, it's going to be hello.sql for both of them. So we can do this, and we should see a nice little diff of what changed here. So there is a diff output here. It's not colored up here, but, we can see, I reloaded a lot of different times there on my machine here, but we can see the diff here that it added whatever, rows, I'm squinting here because zoomed in a lot, but like rows 6 to 17 here. You can see row 9, 10, 11, 12, the ones with the plus sign here. These are all new rows that were added in the newer one after I reloaded a couple of times here. And we could see all sorts of different things like different timestamps and blah, blah, blah. But yeah, this is pretty cool. We can see a complete diff of what changed between those two snapshots, which I really like, which is pretty nice here. You can even see down here, like the ID sequence here went from 8 to 17 because now we have 17 rows there, which is pretty cool. So that's a little bit more information there to get some diffs between your backups. Maybe you're trying to pull something out specific, you can totally do that here. But yeah, okay, so even if you have these daily backups overwriting each other, right, we're not really supplying something like a year, month, a day, Plakar can still show you the exact difference between each one. And then, yeah, not only that, but like each one is actually standalone. So that means if you have 3 snapshots, you can delete the one in the middle there and still not have data loss. Now, that might seem like magic kind of. So let's understand maybe how deleting chunks and maintenance works here. So with a traditional incremental backup solution, if you had one, you might do like your initial backup, right? That's the full backup there. That's everything. Then you have some new data in your second backup there. And then maybe after that, your third time you do a backup, you have new data B, right? Some more information there. And you'd restore from the beginning of time, right? And it's really important that all 3 of these steps are replayed in order, right? Initial backup, then some new data, then some more new data. So if step 2 were deleted, like over here, then you'd have data corruption there since none of that data would exist anymore, right? That's what a traditional incremental backup and restore. But Plakar, it doesn't work like that. So if the data itself is decoupled from the snapshots that you see when you run something like the ls command. So we need to manually handle those deletes to keep things tidy based on what makes sense for our backup strategy. So without going too deep into how the closet engine works, you can sort of think of snapshot IDs as a shopping list, right? It's a list of items to obtain where the underlying closet data storage engine is the store to obtain the chunks from. And this isn't exactly how it works, but maybe conceptually it could help visualize some of this stuff. So like you can imagine having the snapshot here, right? Going back to our examples before, maybe this ls command here, sure. You can imagine having some snapshots here in the older one, right? Which would be the bottom one there. And that might contain chunks A, B, and C within the closet engine there. And then the newer snapshot there, it might have chunks B, C, and D. But since chunks B and C, they exist in both of them, then yeah, closet is going to dedupe them, so it's only stored on disk once. And then also, yeah, that compression there is handled by Plakar as well, or closet more specifically. So in addition to that, think about closet holding onto your data forever by default, right? In other words, let's say that you added 100 megs of data today, and then tomorrow you delete 20 megs of that data. If we never did a prune or a maintenance or anything like that, then it's going to grow forever because Plakar can't go back and delete the data from a previous snapshot, but it can go back and reorganize things and reclaim that disk space when we perform a maintenance action to do the actual deletes here. And by the way, this doesn't really only apply to deletes, it applies to updates as well. For example, imagine on day 1, a customer signs up here, fills out their profile with some data, but then they change it 3 days from now. With something else. Maybe they change their address or their email address or whatever happens to be there. Then Plakar is going to have both copies of that data, right? From the snapshot from 3 days ago with the old one, as well as a new one here. So that's why it's really important to still think about pruning data based on a time frame that makes sense to you, such as keeping backups for 7 days here, which we're going to handle pretty soon. But yeah, you can actually experiment with this one here if we want to delete the earliest snapshot. So we could go and just run an rm command here with -apply on whatever snapshot that we want to delete. So let's go and actually do that. So if we go here, and then, we run an ls there, we can do an rm. Let's not run it with apply just yet, but, let's say we want to delete that oldest snapshot there, right? We could do this and then pop it in here and do rm. And then it's going to be like, what it would do is delete this here, but we did a dry run basically, and then we could do apply if we want to proceed here. So let's actually do it here. So let's go and run apply, just like it says, and then we can do this here. And then it's going to be like, okay, cool. So like it did removal of this snapshot ID here. And if we do an ls here, we can go and see that that ID has been removed here from the list. It has not been removed from disk, but it's been marked for deletion here. And yeah, going onto more specifics here, we can actually do a maintenance here on the repository that we have here. Yeah, let's run this one as well. So we can go and run maintenance here, maintenance. So there it is. It actually didn't do any removals on disk yet, but it did mark some things for delete here. So let's go and take a look here. Technically nothing was deleted yet due to that 7-day grace period that Plakar has set up for deleted snapshots here. You can see that over here. This is actually completely independent of our strategy to keep 7 days of backups, by the way. This is something internally managed by Plakar. So if you were to rerun this maintenance command again, let's say a week from now, then it actually would clean up that on disk. But here, again, it's been marked for deletion, and in 7 days, then it will be deleted. So when we run the cron job, what we're going to end up doing is basically running this command every day, and eventually it's going to start deleting things as needed once those marked for delete once past the grace period there. So with that said, again, the ls command, it's not going to show this anymore because, yeah, it's been marked for deletion here. And there's a lot more documentation here if you go and want to check out this. Plakar has a ton of really great docs around all the internal workings here, which would be too much to go on in this video here, but yeah, it's all there if you go and want to check it out. Now, moving on here with the post, we are going to create a 7-day prune policy, just like before with the -- today flag. We want to keep 7 days worth of backups here. And, knowing a little bit more on how all this is handled here, we can configure a policy up with Plakar to do what we want here. So we can actually create the policy here. It's global. We don't need to add the @local here. And what do we want to do? Well, we're going to add a policy. We're going to name it something that makes sense. It doesn't matter what it is, right? But in this case, like delete backups older than 7 days. Then we're going to configure this policy here to be like, okay, we're going to keep 7 days worth, and we only want a maximum of 1 per day. We're going to see how this plays a role here in a second here. So let's run this here. We're going to go here, and then, yeah, add that policy. Nice. And then go back to the blog post here. So that tells Plakar to keep up to 1 snapshot per day for the last 7 days here. Anything outside that 7-day window is going to be marked for deletion here. You can actually do a dry run to test it here. So now we can, on this repository, do our prune that we just created here, and we'll see what happens. So let's run this here. So again, if you made some adjustments to the alias name, you would change it here. But all right, let's do that. And it's going to be like, okay, we're going to keep this one here. Why? Because we only have one of them that exists. Remember, let's go back to the ls here. So there's really nothing to delete here, right? It's going to keep the one that we have. But if we go back to the blog post here, we could do something like make another backup here. So let's do that. Actually, I'm going to update this to include the environment variable that needs to be there. So let's go back and just run another backup here. It doesn't matter if we don't change the data, it's no problem. So let's just run another backup here. Yep, it's going to be done. We do an ls, we should see 2 of them. Yep, and then if we do a prune here, we'll see what happens, which is pretty interesting. So now it's going to be like, okay, well, we're going to delete the older one of the 2 here, right? For example, we have 1504 and then 1515. This is the newest one on top here with the same exact data. And due to the policy that we created up here, the one where we want to keep only a maximum of 1 per day, this violates the policy now because we have 2 of them on 1 day, but Plakar is going to be like, well, okay, let's keep the more up-to-date one, the more modern one. So let's get rid of the old one. So it's going to keep the new one and delete the old one here. But again, it's not going to be deleted right now. But yeah, we can then run that with apply. And then, well, the blog post, does it say to run it with apply? It doesn't matter. But yeah, we can go and run it with apply if we want and then actually do it. But I will mention here too, before we get there, the per day 1, that's part of the policy that's allowing this behavior here. So if we were to actually change that to be per day 2 instead of 1 in our policy, then it will go and keep both of them because we said, hey, by the way, we're going to allow up to 2 per day. So just a heads up there. And again, if you want to go and play around with the stuff later, you can go and take a look here at policies. Then you can always go to this file here and modify this, if you want to just modify that to a different value. So going back down to here, we can go and actually run the -apply there to do it. So let's go back to the up here and run this one, and we'll go apply. And that is going to do it. So now if we go and take a look here at the ls here, then it pruned out the old one, and now we have the new one here from 1515, and we are good to go. So like the rm command here that we ran before, this action again didn't really delete things from disk. So maybe now we could talk a little bit about automating both the pruning and the maintenance here. So you can set up maybe another cron job here, at 8 UTC, whatever it happens to be, a couple of hours after a backup. It'd be expected again that you create this policy on your server, the Plakar one that we just went over now. But yeah, in this cron job here, again, you can name this whatever you'd like. We're going to run some of those similar commands that we just did before, right? We're going to run this as a deploy user. There's the Plakar command. We're going to do @local here because that is the alias that we want. What are we doing? We're going to prune with the policy that we just created here, and we are going to apply it. Might be a little bit hard to read. It's broken up into 2 lines there. And then after that, after we apply the prune policy, then we're going to run our maintenance here. And this is actually going to perform the deletes on disk, after the grace period of 7 days there. And again, those 7 days unrelated to the 7 days that we have here. So yeah, that is going to mark things for delete, actually delete them, etc. And we're going to be in a good spot here. So if this, by the way, looks a little bit too much, maybe for a cron job, you can totally extract that out into a shell script if you want here. I didn't do that for the sake of this post here, but you could totally do that if you'd like. Now, technically, Plakar does have a scheduler agent that you can run on your server. Basically, it's a little daemon that runs there instead of using a cron job, right? The benefit there is you can configure everything together in a YAML file, but we're going to stick with cron jobs. However, if you go and want to check that one out here in the docs, there's really extensive documentation here going over how to set all that stuff up. Personally, for me, I prefer to run a cron job or a systemd timer there, because if it's on a system that I'm in control over, I kind of like having these scheduled tasks all in one spot here at the system level. So if I list all my systemd timers or cron jobs, it's really nice to know that's the source of truth. However, on the other hand, if you have a dedicated Plakar server where you have a whole bunch of different schedules going on there, maybe it's cleaner for you to use their scheduler agent, in which case then feel free to use that instead. Really, it's up to you there. But it's really nice that Plakar gives you that flexibility here. So yeah, let's revisit that daily backup cron job, by the way, that we talked about before. So, this is going to be the PG backup hello one that we had. All this will stay the same here. But yeah, now instead of running PG backup hello like we did before, we're going to change that one to support our Plakar storage repository just by passing in that environment variable that we had before that we want to. And now when we run that, then the cron job is going to do daily backups here with Plakar. And then when it comes to restoring, because we haven't gotten to that yet, now before we wipe and restore our database there, try adding some more data to it so we can actually confirm that that data doesn't exist after we do the restore. So I'm going to go here, add some data to the database 4 or 5 times. I did a reload there. And like with Plakar, you can just do your compose down v to wipe your database. Again, be very careful if you're doing this type of thing in production. So yeah, we could do a compose down v. Let me go over to the server and do this one now. Just control C out of here. Cool. And then we'll do docker compose down v. Then from here, we can do our compose up just like we did before. Again, Postgres will create that initial user and database for us based on the environment variables that we had. That's just the benefit of the official Postgres Docker image there. And MySQL will work very similarly. But yeah, now we have another script here to perform the restore with Plakar. So let's go over that script a little bit here. So yeah, let's take a look here before we actually do the restore. So on the bottom here is PG backup, right? I'm going to open up our PG restore. That's the old one. And up top here, I'm going to do the PG restore and then Plakar. So yeah, we're still going to be passing in things like the Plakar repository, just like we did for the backup. Now it's going to be PG restore, sure, the project name that you want. But now, we need to pass in the snapshot ID. So looking on the bottom here, we used to only run either PG restore or maybe the timestamp that we wanted if we did -- today. Well, you could think of this snapshot ID as very similar to this, right? We need to pass in something to restore from, but there's no option to where, we wouldn't restore from nothing. Now, if you wanted to, you could make this a little bit different, right? Where maybe this is optional. And if you don't pass in a snapshot ID, you can have some logic in your script here to get the latest snapshot ID from doing like an ls or whatever you want there. But yeah, I kind of like being super explicit on what I am going to be restoring from, because let's face it here, you're restoring your database backup. So yeah, knowing which one you're restoring from is probably a good idea. So yeah, I like always explicitly passing it in. So yeah, we pass in the project, we pass in the snapshot, we deal with the same logic as we did before with the passphrase, right? Either get it from the file or the environment variable. And then it is going to run a command here. Let's get rid of the one on the bottom. Now, I guess before I close it here, we did do the gzip here. We have the plain text version of our dump, and then we pipe that right into PSQL. Cool. So we're going to do the same thing here, slightly different, but same concept. We're going to take the plain text output here from Plakar and then pipe it into the PSQL command. This is the same command that we ran before in the other restore script. But now we're just doing, Plakar picking our repository. Then we're going to use cat here, which is going to basically output, the contents of the snapshot ID, as well as the file that we want here, which again is going to align with the project name here. So let's actually maybe run this one without using the script here, just so we can see some more details about that. So if I go over to the third one here, we can do our alias, just like we saw before here, that 59C here. So we can go back to the shell script and be like, okay, well, we need to run Plakar at, and then, yep, whatever, okay. So we can do Plakar at, and then local. Then we're going to cat this, and then what do we need to do? Then we're going to put in the snapshot ID, colon, and then hello.sql. So we're going to do the snapshot ID, colon, and then hello.sql. And you could put a / here too, it doesn't matter. And then once we have that here, that should be the whole command here. And this should produce our dumped backup from before. And there it is. We can see everything there. There's our, should see 17 rows, right? Because remember, we did the backup back then when there were 17 rows. However, when I did those reloads before, there was a little bit more. But yeah, this is the restoration file. But we didn't actually do the backup yet, right? We just ran this to see the output of that one. Okay, that's cool. Then it's like, yeah, it's going to pipe it into here, and then we can actually do it. So let's actually do it here. So we're going to run this here. So copy that. Yep. And then paste it here. Like this. Although in this case here, you're going to have to do / here because, it's relative to the current directory. I actually don't have this on my system path. And then when it comes to the snapshot ID, then of course you'll put in yours. In my case, it's going to be 59 CF 9206. And this is going to perform the actual restore. So let's go ahead and do that. And there we go. No such file. Oh, duh. Yeah. You need to put in the real one, which would be hello. Cool. Yep. That's a good idea of just like using the correct arguments there. But yeah, in this case here, everything is good to go. Our dump was imported successfully. And now we should do a pSQL here. Let's go and check it out here, run pSQL. And if we do our select, let's just do ID from request logs, then we should see 17, right? That's from our restore. And I guess technically, sure, let's just do star so we can see all the details there. But yeah, this was all from that restored file. Now directly into our database, good to go. We've restored successfully from a snapshot using Plakar, which is pretty cool. So yeah, just going back to the blog post, we kind of went over all this stuff together here before even going as far as cutting this out, because this could be interesting maybe to run manually in case you want to see the contents of that before you actually perform the restore here. Now let's get ready here for changing things up a little bit to have S3 be the backend instead of local storage with Plakar here. So before we move forward with S3, it's going to be expected that you do have an AWS account and a user with at least the permissions to create and interact with an S3 bucket here. So in my case here, I've got my user here, it's an administrative user. I also created a Plakar user, which we're going to create some stuff for in a second here. But yeah, and it's not going to be a full-blown AWS tutorial. Feel free to check these things out as needed. But yeah, going back to the blog post here, we'll mention here too, again, if you set up things before in the S3 bucket to have that lifecycle policy, you want to make sure to delete that one here because we definitely don't want that policy to start deleting files that Plakar is going to manage in that bucket. So again, going back to lifecycle policies here, you want to make sure this is empty, or at the very least, it's not going to have any lifecycle rules to delete older files in there. So yeah, going back to the blog post here, before we go any further, it's worth pointing out that Plakar's S3 integration, again, I mentioned this before, it is going to work with any S3 compatible API. That means DigitalOcean Spaces, Backblaze, all sorts of other ones. That's pretty nice here, but we're going to be focusing on using S3 directly here. And you don't need the AWS CLI installed because again, Plakar is going to use that S3 API directly here. Then just go ahead and create your bucket on S3. I've already created the bucket here. Let's go and open it up again. But yeah, I'll just make another bucket. I'm not going to use that bucket, but I'll just like play around with some of the UI stuff so you can see it. Right, we're going to create a bucket in whatever region that you're at. It can be general purpose. It could be a global namespace. You can also lock it into your account if you want. It's really up to you. Here is like where you'd put in the bucket name. Feel free to pick whatever bucket that you want. Since it's global, it does need to be unique across that region there, just to be mindful of that one. And you'll want to make sure that Blackwell public access is enabled on the bucket here, most likely, right? Because this is your database backup. I would say you almost certainly don't want this one to be publicly accessible on the internet. This will lock things down to where you do need IAM permissions here to get the contents of the objects in that bucket here. Whether or not you want to include versioning is up to you. And then, yeah, it's going to be encrypted at rest by default with S3. So going back to the blog post here, so yeah, going back over here, we created the bucket. It's going to be encrypted at rest. It's private, and we are good to go here. We can leave the defaults to everything else. So if you wanted to create the bucket there, you could totally do it. I'm going to cancel it out here because I already have the bucket created over here. All right, so going back to the blog post here, then it's going to come down to having AWS credentials here. So this would be both your public key and secret access key. Now, if you've used the AWS CLI before in the past, I'm not going to show this one on video, then this path here will have your secret key and the public key as well. But if not, maybe you have them saved somewhere else. If you lost them or whatever, then yeah, let's go and create some new credentials together here. So yeah, under IAM users here, you can find whatever user that you want to operate under, and then go to security credentials here. So in my case here, I'm going to be operating under a new IAM user that I just created here called Plakar. And, by default, you're going to be on this tab here. So we'll go to security credentials. And then, yeah, in this case here, the Plakar user, it doesn't need console access. It's only going to be command line access. So again, it's up to you if you wanted to use roles or users, or yeah, it doesn't really matter how you want to manage this stuff on the AWS side. It's really your call there with security, but here is where we can create access keys. So let's go ahead and do that. So we're going to go here, just choose other. Doesn't really matter a whole lot here. But yeah, when we do that, then we can either add a description if you want. We can also leave it empty here, and we can go and create our access key. So there is the access key here. I'm going to copy that and save it somewhere. Right now, I am just going to probably save it in a file here, like AWS creds. This is only temporary. I'm going to be deleting this file afterwards. I just don't want to lose this in my clipboard because, if we go back to here, we're not going to be able to see this key anymore after leaving this page. So I'm going to copy that here and then do that and save it, because we're going to be inputting the stuff into Plakar commands in a bit here. And by the way, I don't care about blurring this because I'm going to delete this user after this video here. But yeah, make sure you have both of these keys copied. This one you can always find anywhere in the UI, but this one will not be shown again. So make sure this is saved somewhere temporarily in a reasonable spot. So yeah, we're going to be done there. And then now if we actually go to our security credentials here for access keys, we can see we have an active key here. And again, you can create a second one if you want. You can always delete or deactivate these keys later. Really, again, that's up to you on how you want to deal with your AWS credentials. But this will allow the Plakar CLI tool to contact your AWS account and then manage stuff in that bucket, which is exactly what we want to do. So going back to here, that's basically, all this paragraphs here. We have our secret keys and our public key as well. So now it's time to get Plakar CLI ready to use S3. So, at this point, we've gone through the local storage example in this post. If you're skimming around the video or the post, that's totally fine, but we're really going to only cover new information here or, some of the differences there in detail. We're not going to rehash all the same details that we did before. Now, before we create this S3 repository backend, we do need to install the Plakar S3 plugin. Keep in mind, this name is not related to the name of our store. We're going to name it S3, but yeah, this is the official plugin here. Happens to both be named S3 out of coincidence. Now, there's two ways to do this one. One of them requires authenticating with Plakar, and the other one does not. And throughout the video, we're going to do the one that doesn't require that. However, if you do want to do that, you can go and create an account on Plakar, and then, when you run Plakar package add S3 here, you can log into your Plakar account, and then you'll be good to go. If you're trying to do this on a server, you can also do it in different ways here. I'll mention that in a second here. Now, option 2 here, though, is you can compile the S3 plugin on your own here, and then, either do that on your server or maybe do that on your dev box and then transfer it to your server, assuming the CPU architecture matches there when you do the compilation step, because you might be compiling on something like an ARM64 Mac, but then sending it over to an AMD 64 server. But again, we're going to go over ways to do this in a cross CPU architecture compatible way, even cross operating systems as well. So yeah, option 1 requires you either creating an account, and then using GitHub OAuth to sign in there. If you were to download the plugin on your server, you can also create a token with Plakar that lets you sign in to download that binary. So Plakar's documentation here has all sorts of details on how to do that if you want. These are basically command line tools here you can do to, log in however you'd like here. But yeah, there's that. But we're going to go with option 2 here and also leverage Docker so you don't need to set up a Go build environment on your dev box or server or wherever you decide to do this from. We're also going to do it in a way where you can basically just copy paste one command here and then also use the official Go image from the Docker Hub. So since your server, likely has Docker installed, right? Because we're using a self-hosted Postgres or MySQL running in Docker, you can run these commands on your server once to build and install the S3 plugin, or if you want on your dev box, you can run it as well. And then, again, move the file over to your server. So what this script here is going to do in the end here, it's going to grab the version of Plakar that we've been using in this post. By the way, right here, 1.14. If you're watching this video or reading the blog post in the future, feel free to change this to be whatever version that you have when you ran Plakar version, update it as needed there in the curl command. And then it's going to compile the S3 package with a version that's compatible with the version of Plakar being used here. So I do a mention here too, if you are running this on an ARM64 device, maybe like a MacBook M4, M5, whatever it happens to be here, then feel free to add this flag here to ensure it gets outputted for Linux AMD 64 here. Because yeah, ultimately we are running this in a container and it will be moved over to, let's say, a Linux server, right? So in this case here, we can copy paste this. Again, modify this as needed here. So let's go back to the terminal and make sure you're in your directory here where everything was set up. Let me cancel this out and then clear it, I suppose. So yeah, what's going to happen here is, it's going to run a container. It is going to volume mount the current directory that you're in right now to a /output directory inside the container. And then that's going to be the worker. So all these commands are going to run in the context of /output in the container. So the image that we're going to be using is Golang Alpine. This is from the Docker Hub. It's the official Golang image here. And what we really want to do here is install a couple of dependencies, curl, get, and make. Then we're going to curl down the binary just like we did before in our dev box, but now it's going to be done in the container. And we're going to have the Plakar binary here. And then we're going to go ahead and just run the Plakar package build S3. So we're going to run this all in the container here. Nothing's going to happen on your dev box in terms of installing get and make and all that stuff here. So now it's going to do its thing. This may take, I don't know, maybe a minute or two. It really depends on your machine. I'm running a machine from 2014 here. So yeah, it's quad cores, not even like virtual cores, like it actually has 4. So yeah, this could take a while. So I'm going to pause the video and I'll come back when this is done building. Nice, there we go. We can see everything built successfully here. And if you go and take a look here at the current directory, you'll notice that you have a file that was created, a ptar file. Now, the file name might be slightly different depending on when you watch this video, but this is, the packaged plugin here for S3. So going back to the blog post here, you can say, after a minute or two, we have it. It's all good to go here. And by the way, if you're not using Docker Desktop, I'll need to do this step here because I happen to not be using it here. I am on my laptop also running Linux. I've done videos about that one in the past. But yeah, this file is going to be owned by root. So if we take a look here at the file again, you can see it's owned by the root user because the container is running as the root user. But if you're using Docker Desktop, you don't need to worry about it. But yeah, we just need to change that over to be your actual user on the system here. So I'll do that. And there we go. So now if I do an LSLA here, you can see that it's owned by Nick now instead of root. We want to do that just to make sure all the permissions are lined up here. So now we can actually finally add that S3 package here from this ptar file that we had here just by doing Plakar package add, and then we can do S3 star and then ptar here. Because again, the file name might be slightly different depending on when you watch this video, but the star and pattern here is going to capture whatever file name that you had. So you can copy paste that there. Now, this is pretty cool because, well, I already had this package added to Plakar here, so it's not going to try to add it again here. But in your case, you'll see some successful output there. You can see maybe some details like this. So now you can verify it's been added just by running, package list there with Plakar. So let's do that. Plakar, pkg list here. And then you could see there it is, S3, and then whatever version that was built here, in my case, it was 1.12 here. So nice, okay, cool. So now you actually have that. You can actually delete that ptar file on disk here, in the current directory, just like this. And then, LSLA, it's gone there, it's good, but we still actually have the package installed because again, we just deleted that file on disk. So now we're in a position here to be able to actually use that plugin package that we just installed. However, I will mention here too, and we're not going to follow along here, but if you wanted to, you can just do a package RM on S3. So yeah, when you do a package list here, it includes all sorts of different details about it. You just need to pass in S3 here if you wanted to remove it. And if you wanted to update this in the future doing it this way, what you could end up doing here is just remove it and then add it again here, and that will give you the new version and you'll be good to go. So with that said, now we can create a new alias here, but instead of using local, we are going to use S3. And you could see right away, there's all sorts of different things that you may need to change here. It's a little bit more information, right? We need to pass in the region of where the bucket is, or, basically the URL here for the bucket. And again, you'll want to replace that with your bucket name. And then also you need to pass in your, public access key here, as well as the secret one as well. So I'm going to grab this whole thing here and then go to my code editor, just like we saw before. And then here, and then I'll start assembling that command just so you can see how it's done. So, if you're not using US East 2, then feel free to change that. Your bucket name is going to be different, but then we can also go here and just grab that as the access key. And let me actually copy that and then paste it. And then we'll do the same thing for the secret key as well. So copy that, and then we can go and paste it here. And then that's that. So then we can go and run this command here in our terminal. Right now we're just doing another alias here for S3. Again, we're going to name it S3, but it can name it whatever you want. So here we go. We do that. And then it's going to be added. And if we go and take a look here, at the blog post, you can do some confirmation steps here. Your key is going to be saved in this file here in stores, just like it did before. So if you want to go and check that one out, there it is here. We still have our local one because, this can support multiple stores being saved. But then, your AWS keys are here as well as the location as well. But we can do even better to confirm this actually works. So we could do, store show S3. So let's do that. So we can do Plakar store show S3, there it is. In this case, it's going to mask out the sensitive data for us, which is pretty cool, if you're doing like a live demo or something like that. But you can even go one step further here and make sure that your credentials are good by doing a ping instead. So let's go back here and we can do store instead of show, we're going to do ping. And then that's going to show configuration okay. If your keys were messed up, maybe some value here isn't good. So I go into NeoVim, and then let's say we change this A to be a 1. And then I'll just change that back to A in a sec. But if we do a ping now, you can see access denied. That means maybe there's some, difference here with your access key. Maybe you forgot a character. Maybe there's like spacing or something there. So double check that if you get that problem. Maybe your key expired on AWS. So go and check that out as well. So just make sure before you continue, you can actually do a ping here. It verifies everything is good to go here. Nice. So now we can go and configure S3 to be our setup here as our Plakar repository that we're going to be operating under. Now, up until now, everything we've done on AWS was free. So creating an AWS user is totally free. You can create credentials, no problem. You can even create an empty bucket there with nothing in it, and that's not going to cost anything. But as soon as we run this command below, then that is going to create files in the S3 bucket that's managed by Plakar. And that's going to start to be a billable event, right? Some fractions of a penny or whatever it is. So just a heads up. So yeah, let's go and run this here. We're going to create our backend here for S3, and then we can go and take a look. We can actually go into the S3 bucket itself, and then you'll see a single config object. So let's go here and go to the bucket that we have, which is this one here. I only have one bucket in this account for this one, but now we go in here, we can see that there's actually one config file here created by Plakar. Nice, so far so good. But now we have an interesting situation here. So we were playing around using the local storage with Plakar, and now we have S3 storage. So what are we going to do? Do we want to just delete the local one, recreate the backups in S3, or maybe do we want to sync the local to S3? It's really up to you. And we're going to do the sync one just so we can see it work. So I wanted to call this out, right? Because Plakar can actually sync your backups from one repository to another, right? Such as local to S3 and vice versa. Super useful to know, because maybe you want to just migrate to S3 after trying things out for local, but you don't want to rerun all your backups or whatever and lose the stuff that you had. So yeah, let's go and check that out here just by running the sync command here. So you can do a Plakar, and we're going to do @local because we're going to sync that over to S3. So it's like, the source and the destination. You can think of it like that. So let's go to our terminal here and run that. Now, even if we have the environment variable exported to our terminal, it is going to ask us for the destination passphrase. So let's go and take a look here at the passphrase here, just so I can copy paste it to my clipboard. A little bit easier, right? And then I can rerun the command here and then just paste it in. Yep. And now it's going to synchronize that snapshot there from local to S3. And if we go and take a look here on S3, go back to that bucket, then we can reload this and we would expect to see some of the contents there of the backup that we had there from Plakar. We're going to do a lot more to verify that's actually working, but yeah, it's one way to go and check it out there, right? You can see some files and folders there, and we can actually compare both of them because, now we actually have two backends running together. Now we can actually do an ls here on S3 as well as local. So let's go and check it out. So we can do Plakar, @local ls here, and then we can do the same thing for S3. Might take a little bit longer, whatever, doing some network calls there, but you can see the IDs and timestamps and all that matches up here, right? Because these are the same things, right? This one took 1 second, this one took a little bit less. So that's pretty cool here too. You can see the same snapshot ID, whatever. So now we can actually delete the local repository if we want to, right? Because everything right now is backed up on S3, which is pretty cool. Again, this is up to you on what you want to do here, but yeah, you can RMRF that backup directory to fully and permanently delete your local backups, right? For anything that you had there. Again, be careful if you have other stuff in there as well, right? But since we want to use S3, that would make sense, right? We don't want to really have the local one as well. But since we've only used local storage there as a primer on getting used to working with Plakar. So I'm not going to delete it on video, but you can, but it's up to you. Just don't forget to do that in the end if you're cleaning things up here. And then we can also technically, if you wanted to, delete that alias that we created for local as well, because we don't plan on using it anymore. So actually, let's do that here. So let's do that, and then we can run this. And then, yeah, if we go and take a look here at that stores, then we just have the S3 one there. I actually should update my little blog post here because it's not going to be empty. The S3 one will be there. Also, let's keep that Plakar policy here because when we use S3, we'll use the same one there. That's the one that's going to do the pruning after 7 days there. So yeah, now let's go over backing up and restoring with Plakar over S3. And we're going to blaze through all this here because we ran a lot of these commands before. So feel free to maybe add some more data to your running application here just so we can see some new things here. A couple of reloads there on the page. Cool. And then for the backup here, instead of doing @local, we can just do @s3 here. Our script is already general purpose here. We don't need to modify a single thing. So let's go here and grab that command here. And then again, running this in the terminal, we can see our repository is S3. Let's do it. Doing our backups there, taking a little bit longer, totally normal. It's writing all sorts of different things to S3. We could do our S3 ls here, and we can see 2 backups now. And there it is. Sweet. So go there. Nice. There we go. Cool. And then for restoring, you can clear your database by doing the usual compose down v, and then we can do our restoration here. So let's do that. So here, control C that out, and then docker compose down v. We'll up again. It's going to give us our fresh database. Again, that user is going to be created with an empty database, etc. I'll just wait until this initializes. Nice. And then we can go and just run our restore just like this. So when we run the restore though, remember we need to pass in the snapshot ID there. So let's go back to our terminals here and just instead of putting in this one from the blog post, again, modify this with your name here. And again, we have to do a / here, put that in there. Because again, I read the blog post and the contents of maybe put that on, use a local bin on your server. That's why I didn't put the / in there. But yeah, in this case here, let's go with the newest one, which will be the one on top there, the 089. Again, that's going to be different on yours. So E0, E0E. Cool. Okay. So let's do our restore here again, pg restore Plakar. Going to do that from an S3 restore. And there it is, familiar output that we've seen before. And if we go and do our run pSQL and we do our select star from request logs, then yeah, we actually have more than the 17, right? Because as you just saw a minute ago, I went to the browser, reloaded about 3 times, it looks like, and there's 18, 19, and 20. So we just did a successful restore from Plakar using S3. Very nice. And just like before too, by the way, we can also do the cat on a specific one here to just see this information here, maybe before you do the restore in case you want to go and check it out. So let's go and kill this out here. And I'll do an ls again, just so we can get that reference there for the snapshot ID. And then in this case here, we are going to get rid of this and then put in that, 089 one, E0, E0E. And then there it is. And then we should be able to see the output there. Cool, there it is, and everything is there, good to go. Now going back down to here, we can go to the cron job now. If you had this set up on your server, we do need to make a couple little tiny updates here, right? Instead of using @local, we're now going to be using @s3 here. That's in 2 spots here. So just make those updates. Again, that prune policy is going to be the same here. And yeah, the call is going to be the same for maintenance as well, minus the change there for the repository. And also, if you stick to using S3 here, this other cron job that we had to delete those old files on disk but find, that can go away now, right? Because the backups are going to be saved onto S3. In fact, if you kept this in here, it's going to be throwing errors here because the path won't exist anymore. So yeah, in that case here, you can delete that cron job there if you're using S3 backups. And we're basically done, right? But this is a really great example of the power of abstractions here. Look how little had to change when using Plakar to switch between local file storage as well as S3. And once we had that store configured there, yeah, everything else was the same, right? And then with our prune and maintenance cron job running from the previous section, with the local backups there, our bucket is going to be kept under control there with how much data we want to keep around here. Now, just to wrap things up here for cleanup, right? If you wanted to delete your backups there on S3, you can just go to your bucket here, empty all the objects out and delete them. You can even delete the entire bucket if you want. It's really up to you here. But now that you have data in that bucket, don't forget this step. Again, if this is throwaway data here, you don't want to keep that lingering around and getting billed for it on AWS here. So that is about it. I mean, we covered a ton of ground here in this video, all sorts of different backups and whatever. I don't know how long this video is, well over an hour here, but yeah, 7 tutorials in one here. Hope this gets you going here for backing up your databases. And don't forget to check out Plakar here. It's all open source here on GitHub. They also have an enterprise offering as well if you just want to have a nice little graphical interface for managing this stuff instead of using the CLI. So feel free to check that one out. With that said, if you have any questions, let me know in the comments below. I'll do my best to answer all of them. If you liked the video, please give it a thumbs up. Really does help a lot. Thanks a lot for watching, and I'll see you in the next one.